Hey there, friends. I'm going to take you through this last problem where you're given a graph and then you have to determine the equation of it or the function. It's going to involve a dilation. And it's the first one we've done, so I thought I'd take you through it. Here's what you do. You first analyze it. You want to make sure that you match which parent function it is. You should be pretty good at this one. This is, as we look at it, it's got this shape, that form. That's a cubic. So it's got to have some factor of, or it's not factor, but form of something cubed. I do not see any reflection. It hasn't been flipped over the x or y axis. That's good, so no reflection. And the 0 point, the important point 0, 0, hasn't been shifted at all. So there's no translation either. That's helpful. Then to analyze this, I would lightly just sketch in what the original is. We got 0, 0. We have 1, 1. We have 2, 8. Negative 1, negative 1. Looks like this, this grid is every only the even numbers are shown, so I don't see 1, 3, 5, and 7. And then this was 2, 8. This should be 1, 1. This one should be negative 1, negative 1, and negative 2, negative 8. That's what the original looks like. So sometimes I find that just sketching it in and then the original parent function, then comparing it with what I see is pretty helpful. Well, what do I see? I see a point that used to be 1, 1, now looks to be, is that 1, 1/2? Let's explore further. I see a point that used to be 2, 8 is now 2, 4. Do we have enough to go on? I think so. I think each point is being cut in half. 8 has gone down to 4. 1 has gone down to 1/2. What used to be negative 1 is now negative 1 1/2. This dilation factor is a vertical compression. How do I know it's vertical? Well, because the same x-coordinate exists, a 2 and a 2, but the 8, the y-coordinate, has gone down to 4. So it's the y's that are changing. So I know that it's going to have to be something on the outside of this function that changes the y-coordinates only. The dilation factor is 1/2. Now, if we want something to be cut vertically 1/2 nicely, it's just right out in front of that function. I believe we're working with 1/2 x cubed. It is always good to double check, to put in some points to see if they confirm, and in this case, they do. This is one of the toughest skills, is to see a graph, especially with a dilation, and to work backwards and kind of analyze it and find the original function. Please do not get discouraged too much on this. It's really challenging your brain, and it is really tough.